Hi children, today we are going to discuss the Pearson International Advanced Level PO Mathematics 1 paper, January 2020, question number 3. Before we start this question, shall we discuss the main theories what you need to understand this question? If you need to find the gradient of a straight line, we can use the equation gradient m is equals to y1 minus y2 divided by x1 minus x2, where we have already learned this from IGCSE classes. But if you need to find the gradient of a curve, we cannot use this equation. There we need to use the differentiation and the related theories. When you discuss about this question, we need to focus on below theories about a tangent. If you consider a tangent, we can see two main properties. First property is, if you get the gradient of the curve and the gradient of the tangent, both become equal to each other at the tangent point. The second theory is, the coordinate of the tangent become coordinate of the curve. That one also happens at the tangent point. Now let's start with the question. They have given the equation of the curve is y equals to x squared plus 3x minus 2, and they expect us to find the gradient of the tangent at the point P 3, 16. From the previous theories we know that gradient of the curve and the gradient of the tangent become similar at the tangent point. And we know that since this is a curve, we need to find the gradient using differentiation. So initially, shall we differentiate this function y equals to x squared plus 3x minus 2? I have given all required steps. Therefore, we can understand that dy by dx at the tangent point is 2x plus 3. And if you want to find the gradient of the curve, we need to substitute 3 because the x coordinate of P is 3. If you follow up the steps, we came to know that the gradient of the curve at the tangent point P is 9. Therefore, the answer for question 3a would be 9. When you come up to question number 3b, they request us to find the gradient of the curve using two different points. That is called the tangent method. We can find out another point Q which is close by to P. They have given us the x coordinate of Q is 3 plus h. To find the gradient of line PQ, we can use the formula y1 minus y2 divided by x1 minus x2. Therefore, x1 and y1 become the coordinates of P 316. And in this question, we know the second point is Q, whereas they have given us the x coordinate. X coordinate is 3 plus h. But still, we don't know the y coordinate. And we know that point Q is on the curve y equals to x squared plus 3x minus 2, and the x coordinate is 3 plus h. Therefore, if you substitute 3 plus h into the curve, we can get the answer for the y coordinate of Q. That is already worked out in this question. You can understand that turn up into h squared plus 9h plus 16. Now, if we use the gradient of PQ, y1 minus y2 divided by x1 minus x2, you can get the answer h plus 9. You get the required steps in the worksheet. Let's try to understand how to do question number 3 part C. In this question, they discuss about properties of derivatives. If you want to find the more perfect value for a gradient of a curve using tangent, we need to find 2 points P and Q which is close by to each other. if Q becomes so close to P, you can understand that this H becomes 0. From question number 3 part B, we already found the gradient of the curve is h plus 9. Then if you reach h into 0, you can understand that simply the gradient of PQ become 9, which is exactly same as the answer where you reach in question number 3 part A.